Okay, now that we understand the basic kinds of derivatives, we understand forward contracts and futures, we understand both call and put options and the fact that you can take long positions and short positions, what we're going to do in this chapter is learn about combining all of these instruments in different ways. We saw at the end of chapter 2 that options can be used as a type of insurance, and that's a topic that we're going to explore in a little more depth right now. Options can be used to insure a long position in an underlying asset, and what that means is if you own the underlying asset, like a stock or a stock index, you can use an option in combination with that position to place a floor on the price of the asset that you will receive when you sell it. In other words, to ensure a minimum selling price when you do finally decide to sell the asset. Options can also be used as insurance whenever you have a short position in an asset. Remember from chapter 1 that whenever you short sell an asset, you're essentially making a bet that the price of the asset will fall. So you make money if it goes down, and you lose money if it goes up. Well, of course, the more the asset goes up in value, the more money you lose, and your losses could potentially be unlimited. One thing that you can do to place a limit on your losses from a short position is to use a cap. And we're going to see more about that shortly. Now, of course, whenever you use options to create a floor for a long position or a cap for a short position, you are essentially buying insurance. It is also possible to be the writer of insurance. In other words, it's also possible to write the option. We learned in chapter 2 that for every person who purchases an option, there has to be someone who wrote the option. That is, there has to be a seller of the option. And we're going to explore both sides of that. Alright, let's talk about floors first. Whenever you have an underlying asset in your hands, you have ownership of a stock or a stock index or perhaps something else, but let's just go with the stock index for right now, which would be like a group of stocks. Whenever you have ownership of something like that, obviously you hope it goes up in value. You make money if it goes up in value, but there is the possibility that it might go down. Now, of course, investors are risk averse, and they don't like the possibility that their assets might go down in value. One thing you can do to provide yourself with some protection is to purchase a put option in combination with that underlying stock or that underlying stock index. What that put option will do is to function as insurance against a fall in the price of the underlying asset. And let's see how that might work. Here's a table out of your text showing the payoff and the profit function if you were to have a long position in the S&R index and a long position in a put option on the S&R index. In other words, you own the index, you also own a put option on the index. Now, this put option has a strike price of $1,000. It expires 6 months from today, and the effective interest rate over that 6-month time period is 2%, just like it was for the examples in the previous chapter. Well, what you've done effectively is bought insurance against the possibility that the S&R index might fall below $1,000. Remember that if the underlying index ends up with a value less than that strike price, that is, less than that $1,000, then the option ends up being in the money. We're talking about these cases right here, these cases where the value of the index dips below $1,000, and if you had not bought the put option, you would have ended up losing more money. And of course, there's always the possibility that the index could go lower even than $900, which could cause you to lose even more money. But because you have the put option, as we're going to see, you end up placing a floor on the price of the asset that you will receive when you sell. Okay, let's take a look at some specifics here. First of all, let's suppose that the S&R index ends up with a value of $1,100. Okay, well in this case, you have the index. It's gone up in value. You originally bought it for $1,000. So you've made a $100 profit and you're happy. Now the only thing is that the put option doesn't pay off anything in this case. The put option is worth 0 because the option has expired out of the money. But overall, you're still happy because the total payoff on this is $1,100. And that's greater than the cost of the initial position to set up. Remember, the initial cost of the option was $1,000, and the put option, as we saw in the last chapter, would cost $74.20 approximately. If you combine that together, so you'd have $1,074.20, and you grow it, earning 2% interest over a 6-month time period, that would lead to a future value of those costs of $1,095.68. So that's the amount that you could have earned had you taken the $1,000 that you used to buy the index and the $74.20 that you used to buy the put option. If you had taken that money and earned 2% over the 6 months, you would have ended up with $1,095.68. So that's your cost effectively for this position. But you earned a payoff of $1,100, which is a little bit more than that. The net profit then, considering all of this, is a positive $4.32. Now notice that owning the put option did cost you something in this case. Remember, the put option didn't end up paying off anything, and it cost you $74.20 to buy it, and it could have turned into a little bit more with interest, and so your net profit ends up being only $4.32. It certainly would have been higher in this case had you not purchased the put option. Remember, insurance does have a cost. It is not free, and during those times when you don't end up needing the insurance, like in this case, where the underlying stock index went up in value, in this case you almost end up wishing that you had not bought the put option, because you would have ended up with more profit had you not done so. Let's look at another case where you would have reached pretty much the same conclusion. Let's say that the stock index value did not change. Let's say that it ended up staying right at $1,000. Okay, well in this case you still have the stock index worth $1,000 when you sell 6 months from now, and you have the put option. Of course, since the final value of the index is exactly equal to the strike price of the put option, it's at the money, but it's not in the money, so it still doesn't really pay off anything. The total payoff then is $1,000. Now, of course, the cost of the initial position plus the interest that you could have earned is still the $1,095.68. That doesn't change, and so you end up with a profit in that case of negative $95.68. That's your $1,000 that you ended up with on the expiration date minus the cost of the initial position plus the interest you could have earned on it. So again, in this case, you actually end up worse off than had you not purchased the put option. Remember, again, insurance, it is costly, and sometimes it ends up not paying off, like in this case as well. However, there are some times when you'll be glad that you did buy the insurance. Let's suppose, for example, that the S&R index ended up going down in value to $900. Well, in that case, you would have lost $100 on your position, a full $100. But the put option in this case finishes in the money by $100. The reason why is that, remember, with the put option just considered by itself, it's now giving you the right to sell that underlying asset for $1,000 when the market price is only $900. That's valuable. The put payoff then is the difference between the strike and the spot price of the index, which is the $100. So the total payoff then is still $1,000, even though the value of the index has gone down. Now, you still have a loss when all is said and done, but it's limited. It's limited to $95.68. And that's what happens when you combine a put with the underlying asset. It's not a guarantee that you will never lose money, but it puts a limit on your losses, and that's the purpose of this instrument. The truth is that with this position, even though the table doesn't show it, it wouldn't matter how low the S&R index ends up going. It could go down to $500. It could go down to $100, although that would be highly unusual, and the put option would provide insurance against all of that. It would make sure that the total payoff ended up being at least $1,000, so that the maximum loss you could ever incur was $95.68 on this position. Now here's a graphical depiction of the same thing that we just saw in the table. We see two different positions being combined here. In panel A, basically you see the payoff to a long position in the underlying S&R index. In panel B, you see the payoff to a long position in the put just by itself. In panel C, what we see is the value of the combined position, and we see that the total payoff can never be less than $1,000. And that's why we call this a floor, whenever we combine a long position in the underlying asset with a long position in the put option. It puts a floor of $1,000 in this case on the value of the combined position. Now, of course, once we consider the initial cost of the position along with the interest that we could have earned, we know that we don't always make a profit on this position. After all, that scenario would be too good to be true. So once we subtract the $1,095.68 from the payoff function, essentially over in panel D, what we see is that the profit function is the same shape as the payoff function. It has been slid down by just $1,095.68. That is the cost of the position plus the interest that you could have earned. Now this logic applies to an example that we were just discussing at the end of chapter 2. Remember when we were saying that insurance on your home is kind of like a put option on your home? Well, you as a homeowner therefore have a position just like the one we described. You have a floored position. In other words, if the underlying asset is your house, uninsured by itself, and then you combine that with a put option on your house, which effectively is the insurance policy, then you end up with an insured position, which is represented by this dotted line on the graph here. And of course the dotted line shows that you can only lose a certain amount on your house, which is basically determined by the deductible. Okay, it's fairly easy to see how you can insure a long position. Now let's see how you could insure a short position in an asset. We don't think about this quite as much because most of the time whenever we take a position in an asset, it's a long position. Going short on something is not as common. But let's just see how we could insure a position like that as well. We're going to see that we can. Alright, let's think about this. Let's say that we have a short position in the S&R index that we were just discussing. Okay, so with that short position, we now make money if it falls in value, but, and this is what we're worried about, we lose money when the S&R index goes up in value. And the more it goes up, the more we lose. So, is there any way that we can protect ourselves against a large increase in the value of that S&R index, which would otherwise cause us to lose money? The answer is yes. We could combine our short position with a call option on the SNR index. Let's see how that would work out for us. In this example, this is going to work very similar to the situation we had before, except now we've got a short position in the SNR index instead of a long position. And originally we established it at a $1,000 value. So when we short sold the SNR index, we received $1,000, but then of course we are agreeing to buy the index back later at whatever the price is, and we're planning to close out the position 6 months from now. So evidently we believe that the SNR index is going to fall in value. But what if we are wrong? What if the SNR index actually ends up rising in value significantly above $1,000? What if we end up in this area? What if the index ends up going up to $1,100, $1,200, or possibly even more? Then we would be in trouble. We would lose a significant amount of money. To insure against this possibility, what we could do is purchase a call option on the index for whatever strike price we felt comfortable with. That call option would give us the right to buy back the index at whatever the strike price was. In this case, let's say that the strike price is again $1,000. Now, this is insurance again, and insurance is not free. It does have a cost. And in this case, the SNR call is going to cost us $93.809, so roughly $93.81. That is going to be, again, the initial cost of the insurance policy, so to speak, on this short position. Now let's look at what happens 6 months from now when it is time for us to buy back the stock and return it to the original owner. After all, when we short sell something, that's what we're agreeing to do. If the value of the SNR index has remained at $1,000, well then we just buy it back for $1,000. So that will require a cash outflow of $1,000 6 months from now. So it's almost like no harm, no foul. Except for the interest, which we'll talk about in just a minute. What if the index has gone down in value? Well, in this case, that's exactly what we wanted to happen. If the index goes down in value, then having initially sold it for $1,000, we get to buy it back for only $900. So the cash outflow required 6 months from today is only $900, and that's good. That means we end up making money on this position. On the other hand, what would happen if the index rises all the way to $1,200? Well, that is most certainly not what we were counting on when we originally short sold the index. After all, if we had thought the index was going to go up to 1,200, we wouldn't have established a short position on it. We would have bought it in order to make money. But this time we made a wrong prediction, and we could end up losing that difference. We could end up losing $200 on this. This is why we buy the insurance. This is why we bought the call option. Because owning the call with a strike price of $1,000 gives us a positive $200 payoff. Now, why is that? The call option with a strike of $1,000 gives us the right to buy an asset that's worth $1,200 in the market for only the $1,000 strike price. That clearly has a value of $200 on the expiration date. So what happens is we still have to go to the market and acquire the index for $1,200, buy it back for that amount, and that's going to create a cash outflow. But the call option gives us a positive payoff of $200, and so our total required payout is only $1,000. when the option expires 6 months from today. Okay, so that's the payoff function. But let's make sure that we account for the cost of the initial position plus any interest on that amount. Okay, now this may seem a little strange, but the cost to establish the initial position here is actually negative. So you receive $1,000 as proceeds from the short sale, but you do have to use approximately $93.81 of that amount in order to acquire the call option. Here's what we have as far as the net cost of establishing the position. Now notice that negative $1,000 plus 93.809 is actually still a negative number. Specifically, it's negative 906.191. Okay. Now, what does that mean, saying that the cost of the initial position is negative? Well, it simply means that you receive a cash inflow when you initially set the position up. And then, of course, you can invest that cash inflow at the risk-free rate, multiplying that number by 1.02, since the effective rate is 2% over the 6-month time period, and ending up with $924.32 at the end of the 6 months. Now, of course, you do have a short position in the stock index, and so you are going to have to buy that index back at a substantial amount, and that's going to use up some, perhaps even all, of that $924.32. For example, if the stock index ends up staying at $1,000 and ends up there on the expiration date, well, then you still have your $924.32, and then you also have to buy back the stock for $1,000 at that point in time, giving you profit on this position of negative $75.68. On the other hand, if, as you were hoping, the stock index falls in value, then you still have your $924.32, the proceeds from the initial position plus the interest that you earned, and then you have to buy the index back for just $900, leaving you with profit of $24.32. But notice that no matter how high the stock index goes in value, there's only a certain amount that you can lose. Remember, this is insurance. That was the purpose of buying the call option. Even if the stock index goes up to $1,200 or even higher, you're still going to have a payoff, a total payoff of negative $1,000 as a result of buying back the index and exercising the call. And that's still going to end up as a net result of a profit of negative $75.68. That's the worst case scenario. That's as bad as it can possibly get. Now, of course, this isn't shown on the table, but if we ended up with a stock index value that was even lower than $900, let's say it went down to $800 or $700 or even further than that, then you would start making more money. We don't show these options on the table, but they certainly are there. Here's a graphical depiction of the same thing. Basically, panel A is showing the payoff to a short position in the S&R index, just showing that yes, you have to buy back the stock index on the expiration date. That's what you agreed to do. Panel B also shows what the payoff from the call option would be. And then, of course, we have the combined payoff position in panel C. But remember that you have to account for the initial cost of the position, which was negative, so it was a cash inflow. So the initial cash inflow plus the 2% interest you could have earned over 6 months. So the final result looks like panel D, which is really the same thing as column 5 of the table that we just looked at. Notice that in panel D, again, there is a worst case scenario. There's a maximum possible loss of $75.68. That's the worst that can possibly happen no matter how high the stock index rises. Okay, now one last thing that you might notice is that The diagram in panel D almost looks like it's a profit function for a put option by itself. And if you see that, you'd be right. It is actually the same thing, and we're going to see why just a little bit later in this chapter. You may have also noticed before that when we did floors, the corresponding profit diagram, panel D, kind of looked like the profit function for a call option, and that would have been true as well. They are the same profit function, and we're going to talk about why a little bit later on.